So just like in the last video, here we're going to warm up with what we learned last time. We're going to start off and we need to simplify this. In order to simplify, we need to cancel. In order to cancel, we need to state any restrictions, and in order to state any restrictions, we need to factor our denominator here. Here we're going to start off by factoring both the numerator and the denominator. I have a perfect square in the numerator. I have a complex trinomial in the denominator. Just like before, I'm not going to spend too much time. I'm not going to spend any time showing you how to factor. If you're struggling there, you can watch the other videos. But first, we can break this down into 1 minus 3y squared, all divided by 2y minus 5, multiplied by 3y minus 1. Now here, we have our denominator fully factored, so we can state our restrictions. Our restrictions come from each of the factors in the denominator. First, we'll work with 2y minus 5. So we know 2y minus 5 cannot equal 0, because if it did, it would make our denominator equal 0, and our denominator is not allowed to equal 0. That would be dividing by 0. So here we can rearrange to isolate for our y. We find that 2y equals 5, and we can rearrange that further, so y equals 5 divided by 2. And our second restriction, so that was our first restriction. Our second restriction, we're going to work from 3y minus 1 from that factor. We know that can't equal 0 either. Again, we'll isolate for y. We find that y cannot equal 1 over 3. That's our second restriction. Since we've restricted each part of our denominator, now we can kind of work to rearrange. We're doing this in a slightly different order than we did last time, because we do have a little bit of flexibility. Now I noticed, just like in our previous video, I do notice there's a similarity between 1 minus 3y and 3y minus 1. Okay, those are very similar factors, except one is a negative version of the other. So we can factor out a negative 1 we're going to work with the with our denominator here. We're going to factor out a negative 1 because we're going to choose to work with that because there's no exponent there. So it makes it nice and easy, and I don't want to go into the explanation for working on our numerator here. So we could factor out, let's see, so we still have our 2y minus 5. Now we factor out a negative 1, and we switch the sign of everything inside these brackets. So we're left with negative 3y plus 1. Well, I can put that in a better order. I can make that 1 minus 3y, which accomplishes what we set out to accomplish. That is, the factor looks the same as in the numerator. If the factor looks the same, then I can start canceling because I've already stated my restrictions. So I can cancel one of those factors in the numerator with that factor in the denominator, leaving me with 1 minus 3y in the numerator. A negative 1, I'm just going to rearrange these. Negative 1 times 2y minus 5. Now I have this negative 1 here. I do want my negative to be in the numerator of a fraction, just because that is the way mathematicians like to see it. So we'll put that in the numerator. That's a negative 1 times 1 minus 3y, and we can actually distribute that right now to make that 3y minus 1. We're getting some nice practice in here factoring and distributing a negative number, all divided by 2y minus 5. And then we restate the restrictions. We can't forget this. We know that the restrictions are y cannot equal 1 over 3 or 5 over 2. I'm sorry, y cannot equal. Perfect. So we know how to do that. We're going to rely on some of these skills as we work forward. We'll go back to our elementary school maths. If we're just looking at simplifying a pair of fractions that are being multiplied together, a reminder, what we do here, we multiply their numerators. So that's 4 times 3 divided by 7 times 24. At this point, I can divide out, so I can divide 24 by 4, and I find that equals 6. And then I can actually go even further. 6 divided by 3 equals 2, so I'm left with 1 over 7 times 2. And 1 over 7 times 2 equals 1 over 14. That's how we can simplify through reduction. And we'll take that even further. Now let's handle a problem that has multiplication. It's a multiplication of fractions, except now we have variables involved, so we need to use some of our more recent skills. Well, again, we know when we're multiplying fractions, we can put them together. So that's 6 times x. Instead of squared, I have a cubed now because there's an x in this. In the second fraction, x cubed times y squared times 125. So that's in my numerator. And my denominator, I have 25 times, and let's kind of change up the order here, times 8 times x cubed times y to the power of 5. Because I'm multiplying, the order does not matter, remember. Now, I notice here that I can perform some divisions and some cancellations, but I'm not allowed to do that until I state my restrictions. So we'll state our restrictions here. Remember, we get our restrictions from the factors in the denominator. If a factor in the denominator just has a coefficient like 25 or 8, if there's no variable involved, there's going to be no restriction involved, because no matter what x or y equal, 25 will always equal 25, 8 will always equal 8. We can look at the other factors instead, where I see x is a factor here and y is a factor. X is a factor 3 times, y is a factor 5 times. From there I get y cannot equal 0 and x cannot equal 0. We'll call that the first and second restrictions. So now that we've fully restricted our problem here, we can move forward with our cancellations. 125 divided by 25 is 5. 6 and 8 are both divisible by 2, so we can reduce it here. That's 3 divided by 4. And then if I look at my variables, I see an x cubed in my numerator and my denominator, so I can cancel those out. I see a y squared in my numerator and a y to the power of 5, so that's going to cancel 2 of the factors in my denominator, leaving me with y to the power of 3. Now this looks a little bit messy, but I can keep track, so it looks like I still have a 3 remaining. A 5 remaining, so that's 3 times 5, and that's it for my numerator. Then I look at my denominator. I have a 4 here and a y cubed. Well, I can just rearrange this or follow through with the multiplication here. That's 15 divided by 4y cubed is how I'm left. If this is my final answer, I need to restate my restriction. So x cannot equal 0 and y cannot equal 0. Perfect. Now we'll move forward even further. We'll take it one step further. Yes, here we're going to have variables just like last time, but now we have, it's not only multiplication that's going on in our problem. Within the fractions, we now have factors that are not simple variables or not straight coefficients. Now we have some terms being added together. So let's take a look. Just like before, we're going to start off and we're going to factor, because I need to factor in order to find the factors of my denominators. And once I have the factors of my denominators, I can state my restrictions and then cancel. So I have a simple trinomial here on the right. Looks like I have a two simple trinomials that I'm working with here. It's nice and straightforward. I leave my numerator the same, so that's x plus 1 squared. And in my denominator, I have an x minus 4, x plus 3, times, I leave that the same, x plus 1 cubed divided by x plus 3, x plus 1. Good. Now, I can kind of handle this in a couple different ways. What I would like to do right here, I would like to perform my cancellations. I can't perform the cancellations until I state my restrictions. So I'll call this factor 1, factor 2. Factor 3 is one that I've already done, so I don't need to find the restrictions on that factor, but so we'll call this restriction 3. Restriction 1 here, let's see, x minus 4 cannot equal 0. I can rearrange that to x cannot equal positive 4. Then we'll look at number 2. X plus 3 cannot equal 0. Therefore, if I rearrange to isolate for the x cannot equal negative 3. And my third restriction here, x plus 1 cannot equal 0. Therefore, x cannot equal -1. Perfect. So now that I've performed those restrictions, I can go through with a few cancellations. Now I could perform these cancellations before or after putting everything together. If you know what, in order to make it look a little bit nicer, let's put it together first so we can put it all into one fraction, because I'm multiplying here. So I multiply my numerators and I multiply my denominators. So I'm left with x plus 1 to the power of 2 times x plus 1 to the power of 3. So that's x plus 1 to the power of 5 in total in my numerator, all divided by x minus 4, x plus 3 squared, x plus 1. And I'm realizing here I wrote out my factors incorrectly. So let's just correct those. I'm not going to edit this out of the video. We'll just go through how we fix our mistakes. This should have been x plus 1. Well, if that should have been x plus 1, then that'll actually take away our second restriction because I've already restricted x plus 1 over here. So let's take that out. And we'll fix this factor in the denominator. That should be x. Bear with me. We'll see if I cancel this out. I should no longer have this restriction right there, but I do have it over here in x plus 3. So we'll call that restriction 2. And x plus 1, we already restricted actually because it showed up in our in the bottom of the second fraction. Perfect. So we'll move forward a little bit. Sorry about that mistake, folks. So we should have an x plus 1 squared in my denominator here. X plus 1 squared times x plus 3. If you find that confusing, you can try and work through it on your own, and you should end up at the same spot I am. Now from here, I can perform my cancellations, and I'm allowed to perform my cancellations because I've already stated my restrictions. So I have an x plus 1 to the power of 5 in the numerator, and x plus 1 to the power of 2 in my denominator, so that'll get fully canceled in denominator, leaving me with x plus 1 cubed in my numerator. I can restate this here, leaving me with x plus 1 cubed divided by x minus 4, x plus 3. Restate my restrictions right here. X is not allowed to equal -3, -1, or 4. And we do try and state these restrictions from lowest to greatest because you will have folks a little bit picky in terms of that. Now, how do we divide fractions? How is this going to impact our restrictions on variables? If we're dividing fractions, then I have, say, a fraction a plus b divided by, a over b divided by c over d. Well, when I'm dividing that, what I do, if I remember from elementary school, I leave a over b the same, and I multiply it by the reciprocal of c over d. The reciprocal of c over d is d over c. Okay, so if that's the case, then remember, anything that shows up at any point in our denominator, we need to have a restriction on it so that it can't equal 0, so that all of our steps make sense. Now, if that's the case, then at the beginning, I'll have b and d that must be restricted. And after I perform the division, so if now I have it into a multiplication problem, b is still restricted, d already was restricted, and now c must be restricted. So anything that shows up in any of these three spots at the beginning of the problem will need to have a restriction on it. So it adds a little bit more to the problem in terms of finding restrictions. So in order to find these restrictions, we need to start off by factoring all expressions, right? In particular, we need to make sure b, d, and c, anything in those three locations, or b, c, and d, anything in those three locations, we need to make sure are factored so that we can find all of the restrictions on variables. Then we multiply the reciprocal, we multiply the divisor by the dividend by the reciprocal of the denominator. We know to do that. We've been doing that for years. We'll need to make sure we state our restrictions before we cancel out any common factors. So we'll go over just one example here of some division, of dividing some fractions here. In the numerator of my first fraction, I have a simple trinomial. I can common factor the denominator of my first fraction. I have a simple trinomial of the second, and again, I can common factor the denominator of my second. So let's move forward here. I can factor the first x plus 1, x plus 2. And then I can common factor out an x squared, leaving me with x squared minus 1. That's my first fraction, divided by x minus 2, x plus 1, all divided by a common factor x, 5x squared minus 9x minus 2. Perfect. Now, is this fully factored? No, because I see some of the patterns, some of my factoring patterns still involved here. So this is a difference of squares in the bottom of my second, and I have a complex trinomial in the bottom of my second fraction there. So I can move forward. I'll need to leave, obviously, the numerators the same. So that's x plus 1, x plus 2, all divided by x squared, x plus 1, x minus 1. Again, I leave the numerator the same because it's fully factored. X minus 2, x plus 1, divided by x times x minus 2, 5x plus 1. Perfect. Now that I have this simplified, so I factored all expressions, check. Now I need to multiply by the reciprocal of the denominator. Okay, so let's go through with that. X plus 1, x plus 2, leave the first fraction entirely the same, x squared times x plus 1, x minus 1, times now, let's write that in red so it sticks out a little bit more, times, and we're changing this to green because we're changing everything over here, so we're just writing the reciprocal this time, so x times x minus 2, 5x plus 1, all divided by x minus 2, x plus 1. Awesome. Now, so we've multiplied by the reciprocal of the denominator. Now we need to state any restrictions on variables that were part of the denominator at any point in the solution. I know how to do that. Oops, let's not check that off yet. I know how to do that. That's in positions A, C, and D. All right, so if I'm heading there, we'll take a quick look. A, C, and D, we're finding restrictions. So I'll call it factor 1. X squared cannot equal, whoops, and really we just need to consider x cannot equal 0 here. And then factor 2, that's x plus 1 cannot equal 0. Well, that means that x cannot equal negative 1. There's my second restriction. My third restriction, x minus 1 cannot equal 0, so that tells me that x cannot equal 1. My fourth restriction, x minus 2 cannot equal 0. I can rearrange x cannot equal positive 2. And lastly, I have an x plus 1 here. I've already checked that one in restriction 2, where I said x plus 1 cannot equal 0. So I'm finished here with my denominators. I need to check my numerators. The factor x, I've already checked that one in my first restriction. X minus 2, I already checked in my fourth restriction. Good. So the only new one here is 5x plus 1. Let's get there now. 5x plus 1 cannot equal 0. Okay, well, rearranging that tells me that 5x cannot equal negative 1, and x cannot equal negative 1 over 5. So there are my 1, 2, 3, 4, and 5 restrictions. Now that I have my restrictions, I can start putting it together before I perform any cancellations. So let's see what that looks like. Okay, so I'm left with x plus 1, x plus 2, times x minus 2, times 5x plus 1, all divided by, and yes, it's a big fraction, it's a little bit ugly, all divided by x squared times x plus 1 times x minus 1 times, oops, and there's a squared on that x plus 1 times x minus 2. That squared came from this factor here. Now we can perform any of our cancellations because we've already stated our restrictions on variables. So x can cancel out with one of the x's in the denominator. I see an x plus 1 in my numerator. That cancels out with one of those factors in the denominator. My x minus 2 factors cancel out, and I can see that it's starting to look much nicer here. Let's rewrite this. We're left with x plus 2, 5x plus 1, divided by x plus 1, x minus 1, and then we restate our restrictions. We know x cannot equal, and we try and list them again from least to greatest, so it cannot equal -1, -1 over 5, 0, +1, or 2. So that's how we handle a problem like that. There are plenty of practice problems. We can see it's the only difference really is knowing to flip our denominator into its reciprocal and stating new restrictions there. So you should be able to handle questions like that. Thanks for watching.